Hello everyone, I hope everyone is doing good. Today we're going to start the first chapter of Principles of Mathematics 10 for grade 10 students of high school. And we're going to start with the linear systems, which is the first chapter in the textbooks like McGraw-Hill Ryerson textbook. So we start with two different methods of substitution and elimination methods that is used for solving the linear systems. And eventually we're going to solve a problem using linear systems. So the first method is substitution method. So please see the first example here. We are using a simple example to explain how we use this method. So first of all, you should label the equations. You can label them as 1 and 2. And then you try to isolate one of the variables in any of those equations and then substitute in the other one. For example, in the first equation, so I'm going to find x, which is 5 minus y. And then I'm going to sub in x in equation number 2. So means we will have 3 times 5 minus y equals 7. And then simplify this equation to find y. So this will be 15 minus 3y minus y equals 7. Negative 4y equals 7 minus 15. And y will be negative 8 over negative 4, which is going to be 2. When you found 2, then you can substitute 2 in one of the equations and determine the value of x as well. So I will try the first equation. So x plus 2 equals 5. So then x will be 5 minus 2, which is 3. So the answer of this linear system is this ordered pair of 3, 2. And then you can do kind of quick test and check the answer in both equations as well. So to make sure that you found the correct solution here. So you can try for the left side. Just sub in the answer in the final answer in the left side of each equation and make sure that it is equal to the right side. For example, in the first equation, x plus y, so 3 plus 2 equals 5. So it is satisfied in the first equation. Now we try in the second equation as well. So 3 times 3 and then minus 2. So we need to make sure that it is equal to 7, the right side. So 9 minus 2 will be 7. So the second equation is also working. So we prove that the left side equals the right side. So means this is the final answer of this equation. This was about substitution method. So means we isolate one of the variables and sub in the second equation. Then finally, we're going to have one equation with one variable, which is solvable. And then when you found that variable, then you can solve in that variable in one of those equations to find the other one. Example number 2 is going to be solved by elimination method. As you see from the name of this method, elimination method means we need to eliminate one of the variables. So when you compare these linear equations, just do a quick check or a scan of the coefficients. What do you have? So we have 3x plus y equals 19. And in the second equation, we have 4x minus y equals 2. The coefficients in the first and the second equation shows that if I add these equations, then y minus y will be 0. So I'm gonna add these equations. It's algebraic addition here. So 3x plus 4x, they are the common terms. So this will be add up to 7x. Positive y minus y will be 0. So no y. You can add by 0 y or 0. And then equals 19 plus 2, which is 21. So now you see there is no y. So this part is going to be 0. So eventually you will get a linear equation with just one variable, which is solvable. So now 7x equals 21, and then x will be 21 divided by 7. So the x value equals to 3. Now you can substitute x equals 3 in one of the equations to find the other variables. So I'm going to choose the first one, the first equation. So we sub in the x value, which is 3, in the first equation, plus y equals 19. And then this is a simple linear equation. And you can try for finding y. So y is 19 minus 3 times 3 is going to be 9. So y equals 10. So the answer for this linear system using elimination method is 3, 10. So I highly recommend you to do a quick test with the final solution. Just sub in the answer in both sides of each equation to make sure that the left side equals the right side in both equations. So let's try. So we tested in the first equation what we have in the left side, 3 times 3, and then plus 10. And what do we have in the right side of the first equation? So we have 19. So 9 plus 10 equals 19. So as a result, the left side equals the right side. So it means the final solution, it is satisfied in the first equation. Now let's try for the second equation. 4 times 3 minus 10 equals 2. Okay, I'm trying both ways to show you, even if you don't write left side, right side, is okay. So you can just show that the left side, what you will find as a value in the left side, will be equal to the right side. This question mark here is, I'm going to calculate whatever we have in the left side to ensure that it is equal to the right side. 4 times 3 is 12. 12 minus 10 will be 2. So 2 equals 2. Means the final solution, it was satisfied in both equations. Now we have another example that we choose from Principles of Mathematics 10 textbook, McGraw-Hill Ryerson, page 51, question number 14. And the question is a problem which is based on the solution that we already taught in linear systems. So a total of 27 coins in nickels and dimes are in a wallet. So if the coins total $2.15, how many of each type of coin are there? So what we are going to do, first of all, we have to define two variables. So let's define variables to represent the number of nickels and dimes. So let n be the number of nickels and also let d be the number of dimes. You see two variables here, n and d, both are variable. So means we are looking for two equations that can solve these variables in a linear system. So we should see what are the assumptions in the question. So a total of 27 coins. So means the first equation will be n, the number of nickels plus the number of dimes, which is in total 27 coins. So this is the first equation. And also for the second equation, so we have the second part of this example, which is if the coins total $2.15. So how many of each type of coin are there? So means, first of all, what we can do, so $2.15 needs to be converted to the cents. So it's going to be 215 cents. Since nickels are worth 5 cents and dimes are worth 10 cents, then we can write the equation as 5n plus 10d dimes equals 250. Now you see a linear system here. We can use any of those substitution or elimination methods. Well, first of all, if you see the second equation, all the coefficients are divisible by 5. So I'm going to try this way. So I'm going to divide all the coefficients by 5. And we're going to get the new equation with a small coefficient. So n plus 2d equals 43. So we are using this as 2 prime. So now we have a linear system of two equations. The first equation is n plus d equals 27. And the second equation is n plus 2d equals 43. So when I see the coefficients, I want to try the elimination method. And the reason is, you see the coefficients of n are 1. So means if I subtract 2 prime minus 1, so then we're going to have, okay, n minus d will be 0. So 0n, 2d minus d is going to be positive d. And then the answer will be 43 minus 27. So what we did here, n minus n plus 2d minus d, and then equals 43 minus 27. So here is 16. 0n is going to be 0, so d will be equal to 16. Now we're going to sub in d in one of the equations to find n. So n plus 16 will be 27, and then n can be found as 27 minus 16, which is equal to 11. So the final solution here, n and d, is the ordered pair of 11 and 16. Now let's test the answer. So in the first equation, we're going to try the left side and right side to make sure all are equal. So the left side is n plus d, so 16 plus 11 equals 27. And the right side also is 27. So the left side equals the right side. Also, we do the same in the second equation. So in the left side, n plus 2d. So 11 plus 2 times 16. This will be 43. And then in the right side, we also have 43. And this is another proof that our solution is chosen properly, and this is the final answer for this equation. I hope this video helped you to understand the concept of linear systems. Please add your comments and let me know if you need more examples to be solved, or if you have any close topic to this linear system topic that can help you for your education or for your understanding. Thanks.